This conference will now be recorded.
Hi, this is Rasan Kumar from Isha Training Solutions. I am here with one of my trainings, Cloud Performance Engineering in DevOps. So this is like demo one of two demos. So we'll go over this now. So this is something about me. I have 13 plus years of experience in IT, mostly into performance engineering and development. I started my career as a Java developer. Then slowly I moved into performance engineering. That field excited me. And then I was involved in testing as well. On the cloud side, I have been working from last 3 years, and I'm an architect associate cloud professional. I have also been involved in automation using Java, PL SQL, shell scripting, and Selenium. I'm currently working as an SRE. Yeah. So this will be the agenda of our discussion today. We'll go over the course syllabus. I will set the expectations, what we're gonna cover and how we'll cover. And then post that you can ask your questions or your expectations. What do you expect of this course? And then we can talk about this. Yeah. So before starting the course content, I would like to just briefly touch with a question which is very important, looking at the current market trend. So how many of you would agree that performance engineers or testers or architects, anyone, like there are three technical roles in IT: performance tester, engineer, and architect. So how many of you would agree that we would need to know about these technologies: DevOps, microservices, containers, and cloud? So yeah, so to put things in context, let me go over the software development and deployment evolution, how the software has been developed and deployed over the years. Then these things will be clear, where DevOps fit in, where microservices fit in, where containers come into picture, and where is cloud. So if you look at the software development and deployment evolution, we can clearly see that we have been transitioned from waterfall sometime back, maybe back in 1980s to 1990. So we have been using waterfall for the software development, our SDLC, and then we have been transitioned to agile. We are still in agile, like I would say 60% or like more than 60% companies are still in agile, and they are trying to move it to DevOps, transition to like DevOps. Yeah, so I think everyone would be aware how this uh, waterfall works here. So we develop all the application at once, and then we push to testing, and then performance testing, and then deployment. Everything was designed and developed all at once in advance before going for any testing or any performance testing phase. So biggest drawback was that. So that's the reason we moved to agile here, and where the software was developed in the way of sprints. You consider these things as sprints. So we divided the software development into various segments, and then we divided them in the phases, right? So, and with this DevOps, it is a continuous process. When we talk of DevOps, we'll talk in detail about these things. I'm talking about this DevOps, microservices, containers, and cloud in detail here. Not in detail, we'll take that detail session in our regular session, but I'll go over these topics briefly. So when we talk of DevOps, so it's the continuous development, testing, integration, everything is continuous. Basically, everything is automated. We have automated what all we could not do in Agile, or just to make sure the drawbacks of the Agile gets resolved here. The way we developed, and the major problem was between the development and the operations. So DevOps is made of two words here, if you can notice: dev for development, ops for operations. So operations, we can see like testing people. So once the developers used to develop the application, when testers used to test this application, we used to complain as a testers that this is not working. And most of the time, it happens like the environment is not right. We are missing few libraries from the development, and we're not testing in the right environment. And this slow down the process, operations process, the testing process, and the release cycle. So that's the reason why this DevOps came into picture. And then again, back in 1980s, we talk about the application. We mostly had these monolithic applications where all the softwares were bundled in one thing, like all the layers, your presentation layer, business layer, or DB layer, all are tightly coupled. And the biggest drawback was that if something wrong with one of the module or one of the process, the entire application goes down. So that was the biggest drawback of this monolithic applications. So we moved to n-tier applications where we have 1 tier, 2 tier, 3 tier. We are still in n-tier applications, but we have further broken down into microservices. We'll talk about that in later. So here this has the advantage, like suppose if in a company we have 5 module, business logic, or you can say business layer. So we can, if something goes wrong with one of the modules, the other 4 is unaffected. So you can access those remaining 4 modules. So that's the advantage of this microservices, but this was not the case with monolithic applications. So like if we talk about the data centers, if any company wants to host their applications, they have to own the entire infrastructure. Data centers they have to own, and then we used to deploy those physical this huge capacity physical servers, and just one application back in 1980, just one application in this huge capacity of the servers, and we used to own the servers. So we used to waste a lot of resources here in the physical server. So that's when the virtualization came into picture, and we were able to resolve that particular part of the issue. So where we were able to use the resources efficiently using the virtualization. It was a big revolution that time. When we talk of the VM, you must be knowing about the VMs, that we deploy all our components, application components, software components in different VMs, right? And now this thing has containers have come. This has been further decomposed into containers. So because of this scalability issue, the VMs we were not able to scale properly. So we used to test, and so that was the main advantage of the containers. We were able to microservices architecture, I would say, we were able to resolve the scalability issue. And now this earlier we used to have this data centers, we used to own it, but after some point of time, yeah, there were few hosting providers as well. We used to kind of leverage those hosting provider, and now we are into this transition phase where we have this cloud option. We don't need to own any of the hardware, and still we can run our application. We'll see how that can be leveraged and with how many options we have here. Yeah. So if we have any questions here, please. If not, I can proceed. So you're free to ask anything, anytime you can interrupt me. So yeah, I'm okay with that. So okay, so we'll go over all this DevOps, microservices, containers, and cloud briefly here. So I have just 4 slides here, and then we'll come to our real the content, course content here. So this is how the DevOps look. You would have figured out that this is the waterfall model, where it's a linear state model with design, build, development phase, testing phase, then performance testing, then deployment. We used to skip also performance test. We were performance test at that time. We were not given the importance. Slowly we understood the importance of it. And this was the biggest drawback of that waterfall model. And now this thing came into agile, so the software developed into sprints, right? So it was into phases. We developed the application, and we kept on testing as we are developing it. So it was much better than waterfall. We still, most of the companies are using this agile. Right, but still, the problem was with the operations slowing down the release cycle. So how to make this better? How to automate things up? So everything, like when a developer builds his code, you want everything to be deployed in production, and you want everything to be tested, performance tested, everything checked without bugs. you want automation testing, you want functional testing, you want performance testing, you want security testing, everything you want automated. And that was the main objective why we came up with this DevOps. So if we talk about this DevOps here, so this is the planning phase or the building phase, where the softwares get developed, and this is like a testing phase, and it is everything is, we call it, it is a, if we talk about DevOps life cycle, we have in detail, we'll talk about in our regular sessions. But when we talk about DevOps, we talk about continuous development, continuous testing, continuous integration. We leverage the tools like Jenkins here, or some other tools also. We have the options: continuous testing, continuous deployment, and then continuous monitoring. And with the feedback from the monitoring, we again develop the application. So it's a continuous process. So it is just an improvement from the agile, so next level of the agile. And this is how the performance engineering is integrated in DevOps. So we can be in all the phases. So that's the main idea. So that that's the main ideal case. We want performance engineering to be involved in the early phases itself, in the planning phase, where we can come up with our requirements. So no, this is this, if we are developing this, we'll be testing this out. So setting the expectations on the non-functional requirements. So that's what we call it shift left approach. So we integrate, as a performance engineers, we integrate in the early phases of the development life cycle. So that's the planning phase. We integrate here. We integrate with continuous development phase, and then we always have this performance testing, continuous testing phase, where we test after it's been functionally tested, like automation testers. Everything happens actually automated. So we have to, for the functional testing guys, they would have some Selenium scripts automated. They would have the Jenkins jobs created using Maven. Everything, when a developer kicks in the code, checks in the code, it will build automatically, and it will be deployed in the testing environment without any issues. So earlier we had this issue in the agile, where the libraries or we had this mismatch in the environment. So that's the main reason why we are coming with this DevOps and automation. And we for that we have this Docker containers. We'll talk about this. If things are new to this, you guys don't worry. Just I'm talking about this high level here. So we can leverage this Docker technology to deploy the applications in very quickly. So yeah, so this is the continuous testing phase, integration phase, deployment, monitoring. So depending on the feedback here, what we monitor, we can integrate here as a performance engineering group. We can give our feedback, we can monitor this, we can give our feedback to the development group again. And then if there are any flaws in the design or our development code, we can fix that. So it's not like we are building this application, then we are testing it. It's a continuous process. So basically in the agile, we divided the software development in phases. Here we have divided even further. So that's the main advantage, why we need this DevOps, why this word is buzzing in the market nowadays. Yeah. So we are still in the transition phase from agile to DevOps. Many companies have adopted it, but still many still. So coming to this microservices, what is microservices? I was talking about this microservices decomposition from monolithic to microservices. What are its advantages? So let's see. See, this is the monolithic applications. Back in long time back, we had this all the layers, presentation layer, business layer, data layer, all are like tightly coupled. If something goes wrong with one of the modules here in the business layer, all the system goes down. So we wanted to solve this issue. So SOA came, service-oriented architecture, and then microservices came. We'll talk about that in our regular session. What is SOA and how this has been architecture? So many options in the architecture, software architecture. We have a complete chapter on that. So coming to microservices here, so you can easily figure out that this business layer, a logic. Suppose there are 5 component module here. So we have divided this all the business logic in different phases or segments. We have segmented these things. So if something goes wrong with one of the module, other two are still working. So this is one of the examples I put this. So suppose you are developing one bookstore app where we have this module of accounts, payment, inventory, and shipping. And if you are selecting this monolithic architecture and something goes wrong with account, your entire application goes down here. But where is in microservices? And this because the region it's tightly coupled and it's loosely coupled here. So if something goes wrong with accounts, your shipping, inventory, and payments are still up. So that's the main advantage of this microservice architecture. So architecture designing is very important. So yeah, coming to this containers, right? So why we need containers? So we had this VMs, as I was mentioning, right? We had this virtualization, a big revolution that time. We were able to like use the resources efficiently using virtualization. We had this VM concept where we had this infrastructure. Like consider this as a big box you're working on, and then you deploy this install this software called hypervisor, and then you can create separate VMs. Suppose if your application has three modules, business layer, uh, your presentation layer, and your DB layer. So you can have three different VMs and you can install them separately. But you can notice here we are using all guest OS. It's separate. We have to install the operating system in all the VMs here. Your business layer, your data layer, your presentation layer. What about these containers? So you can see here, this guest OS is not here. So on top of this host OS, we install this Docker engine, right? So Docker is one of the container engine, a popular container. There are other container engines as well, but Docker is the most popular container engine. So you install this Docker engine here, and you just need the binary and libraries, and then your system is up. Your business layer, your data layer, application layer, all these things are, yep, you don't need to install the guest OS separately, because what happens, containers virtualize at the OS level. It uses the kernels of this host OS, and that's the reason we don't need to install separate OS here. So we'll go over, like we have a dedicated thing. We'll go about installing Docker containers. We'll deploy application. We'll see how it is working. Yeah, if we have some time today, we can launch a few containers and see. Yeah. And then this Kubernetes came. So why this Kubernetes? It is the container orchestration engine. Suppose you have so many of containers, many containers. How would you manage this? You use Kubernetes to manage all your containers. So like, to why Kubernetes? Kubernetes basically, Google owns this, but they have donated this Kubernetes to CNCF, and they have been using this Kubernetes for a very long time. And that's the reason that Google.com never goes down. So you can just think of, you can have a rough guess how many people would be accessing Google.com on simultaneous concurrent basis or daily. Huge, right? Consider this, the popularity of this application Google.com, but the system never goes down. The performance is never bad. So that's the main reason they are using Kubernetes. Okay. Yeah, this is the last thing. Then we'll start with the course content actual. So why this cloud computing? What is the need of this cloud computing? So if you look at my this diagram here, this is the on-prem infrastructure. If earlier, if company wants to deploy the application, they have to own the complete hardware. They have to buy land, they have to buy, they have the maintenance scope cost, they have everything, like huge cost. Then they can build their host their application, and then they can run their application. That's the trend for on the on-prem. But now, because of this cloud, we can have all this over the internet. That's the main, you can say, the definition of the cloud. You can have all these things, your data centers, your networking, storage, servers, virtualization, operating system, databases, security, applications, everything over the internet. You don't need to own anything, but you can have your application running securely. And there are various, I would say, the service models, like the infrastructure as a service, platform as a service, software as a service. So it depends on your requirement. You choose between if you want to go as the infrastructure as a service, or platform as a service, or software as a service. So see, why do you, how do you make this selection? Suppose uh, in the infrastructure as a service, this data centers, networking, storage, servers, and virtualization are managed by the cloud provider, and you own this. So basically, you depends on your requirement basically. So you basically own the hardware here. You don't want to purchase the hardware, so you use infrastructure service, and then you can own this, but you would be responsible to manage this. Your cloud provider would not be responsible for this. You have to take care of this if you're opting for this. And yeah, customers are responsible for their operating system, databases, security, and applications. So I was talking to Kripa some time back. So suppose if your application is a banking application or investment, some secure application, you don't want to host your database in the cloud. You're not, you want to be super sure that your data doesn't leave your on-prem environment. So you choose this infrastructure as a service. And we have this advantages here. It minimizes the cost because you're not owning the hardware, no maintenance at all. You don't have to purchase land or infrastructure, nothing. You're just paying for this, pay as you use. So you're just paying for this. In the platform as a service, the cloud provider owns the everything, all the hardware, all these components. You just own the application. Software as a service, the cloud provider owns everything. They manage everything. Consider your Gmail, how it is, your YouTube. It's all like a software as a service, right? Everything is hosted in the cloud. You're just using it, right? So consider as software as a service, right? And we have this deployment models. We have this hybrid, public, community cloud, and private cloud. So it depends on your requirement. You opt for public cloud or hybrid cloud. Hybrid cloud that like this infrastructure as a service you want, or some of the components you want to be in on-prem, but some you want to be in the cloud, public domain. So public domain, the example would be AWS or Google, GCP, or Azure. They are the major cloud providers here. And the community cloud is like a similar based companies, like all the banking companies joined the group, and they told, okay, let's own the hardware in this separately here. So that will be like community based deployment model. And this private cloud, you own the entire thing. It's as good as your on-prem, but you're not managing, but you own the entire DC, the data center itself. Yeah. So that was the brief about why we need this DevOps, microservices, containers, and cloud. This was just a brief on that. So we'll go over detail. This course is the detailed about all this DevOps, microservices, containers, and cloud. So now we'll go over the course content. So this will be our course syllabus, you can say. First of all, we'll see what it takes to be a cloud performance engineer. We'll see what are the skills required. What do you want to learn if you want to be a cloud performance engineer? Cloud will be the future, no doubt about that. There are many advantages of that. You have to learn about this. Yeah, if you don't. So we'll talk about the performance engineering and DevOps. How performance engineering is integrated in DevOps. We just looked into briefly, but we'll go over the detail. We'll talk about this AWS cloud computing, how things are being done, or virtualization. Cloud is nothing but virtualization and automation. We have been doing virtualization for a very long time, but over the internet, we automated things. Keep the hardware somewhere else. We will just use it. We don't want to own this. So that's called cloud computing. So we'll go over this AWS in detail here. Yeah. And then we'll go about this Linux command line. That's very important. So you provision your Linux instances, you work with Docker, Kubernetes, you basically are in the Unix box most of the time, we performance engineers. So we'll go over that Linux command line. We'll understand the software architecture, different architectures. We'll go over the Docker container engine, Docker, in detail. How we can develop the containers, build the containers, and all those things. We'll talk about the Kubernetes, how we're managing things with auto scaling is done. Suppose, yeah, in Kubernetes. We'll talk about the continuous performance testing in CI/CD pipeline. How will you automate things in CI/CD pipeline? Yeah, and then we'll talk about the performance test monitoring and what all options we have when it comes to monitoring. Yeah, and then we talk about the Java. We'll talk about the rest, all the things about the Java. Java is still in the trend, so it's not going anywhere, and most of the applications are still based in Java. So we'll talk about the Java in detail. We'll start from very basics. If you're not aware of this Java, or if things are new to this, it will be a very useful session. And we'll talk about this Java performance and memory management. That's the important part, right? How Java manages its memory. So we'll talk about that. We'll talk about Java collections and how it is related to performance. Why Java collections, first of all. And then we'll talk about multi-threading, concurrency, and performance optimization. So multi-threading is one of why it's directly proportional with performance. But if you're not doing multi-threading properly, it will impact you. So we'll go over this course content syllabus in detail now. Yeah. So as I mentioned, we'll let's understand what it takes to become a cloud performance engineer, different performance related technical roles. We'll go over the roles and responsibility of those performance technical roles in IT. As I mentioned, it's like performance tester, engineer, and architect. We'll understand the roles and responsibility. We'll see the interview expectations, what the interviewer expects from you, and what all skills are required to become a cloud performance engineer. Yeah, we'll go over that. So maybe we can cover this tomorrow or in the Demo1 session. Yeah, next demo session. So we'll understand this performance engineering and DevOps. So as I mentioned that we have this is the DevOps life cycle. We have continuous development here, continuous testing here, continuous integration here, continuous deployment here, continuous monitoring here. How things are being done. Brief about all the tools. We don't need to learn about all the tools. DevOps engineers basically they have to, because they are responsible for automating everything. So they would need to learn about all the tools, but we need to understand, as a performance engineers, we need to understand how things are being done. A good understanding of DevOps is very much required, and so that we can incorporate our continuous testing here in this DevOps life cycle. How can we do that? So yeah, so that we'll go about this, the brief, like in detail in our regular sessions. And we'll talk about this cloud computing using AWS. We'll go over this in detail. We'll create our AWS account. We will own our AWS account, and we'll provision EC2 instances, and we'll connect to the instance. We can show this today. I have one AWS account. I have provision few VMs, the instances there, and we can launch our application. That's the brief that is working, just to validate that yes, you're able to provision the instance correctly, and you can launch something from there. And we'll talk about these AWS services in detail. What is this EC2 compute services? Because that's the first thing AWS came up with, EC2. The first, back in 2006, they launched this guy first. That's just the Linux instance, right? Or the any OS instance. And then storage services, EBS, S3, EFS. We'll talk about this networking. This is very important. So VPC, how the networking is being done, how the communication is being set up in the cloud, virtual private cloud. We'll talk about the security, identity access management here, and we'll talk about this CloudWatch. That's the management and monitoring services in offering from AWS. So we'll talk about this Linux command line. So we will take a lot of Linux. We'll, as I mentioned in the last slide, that we will be provisioning EC2 instance. We'll provision EC2 instance in the cloud, and using that instance only, we'll log into that, and we will practice all our Linux command line. That's the important, because this is the very important knowledge if you want to, because things are getting simpler in cloud, everything is automated. Yeah, so we need to, sometimes as a performance engineers, our responsibility may lie that we need to build the application, or with a DevOps team we need to work and build the application or troubleshoot things up, and everything is Linux. So we have to be comfortable with Linux command line. So these are all the kind of sample few of the commands, and they are all, this will go about the will get as comfortable in Linux as you are with Windows. So we are targeting to that level. So if Linux is something big in your mind, okay, Linux, I don't know how to go about this, you'll be very much comfortable after the session. Yeah, we're covering almost everything. Yeah, how we're comfortable in Windows. So we're talking about the hardware information, how to get hardware information. Uh, we're talking about the file directory commands, user information and management, performance monitoring statistics, file permissions, networking, basically everything. Yeah. And we'll talk about the software application architecture. We'll talk about how this transition is from monolithic services, service-oriented architecture to microservices. We'll see each and every, we'll talk in detail how, because as a performance engineer, we need to know about the architecture to troubleshoot your application, to fine tune your application. We have to understand the architecture, how things are communicating. So yeah, the understanding is very much required here. So we'll go about everything: monolithic architecture, service-oriented architecture, and microservice architecture. Then we come to Docker Container Engine. We'll deploy our own application here. So if you can see, this is from my EC2 instance. I was able to deploy one LAMP stack. LAMP stands for LAMP, LAMP Linux, Apache, MySQL, and PHP server. So I was able to install this application. Yeah, I'll show you. Yeah, after this demo, I'll show you how I have done it. Not how I have done it, so how it looks. And so basically, they are the containers. So if you do a Docker PS, so I was able to create 3 containers. You can see this one container for the LAMP web server, this container is for the MySQL, and this container is for the PHP. And I was able to launch this this LAMP stack in the URL. So yeah, I'll show you that. So Docker, we'll understand. We have something called Docker Hub where we pull the images, and then when we run the images, it becomes a container. It is as simple as that. You can deploy your, that's the main advantage. You can, it is very fast. You can deploy the entire application maybe in 5 minutes, your application in 5 minutes. I was able to deploy this web server, MySQL, and PHP in 2 to 3 minutes. That's it. I had to do this porting up, port mapping, we call it 8080, web server to 8080, and then MySQL to this port 3306, 33060, and this PHP to 5000 port. So I had to map. We'll talk about this in detail. So yeah, so how to do porting things up, how to do networking, and all those things in Docker. We'll talk in detail about this Docker. So you can see for every topic we're talking from scratch. I'm assuming we're assuming that we don't know anything. We're starting from scratch. Even if you know, it's better. Things would be repeated, I would say, but you will enjoy the session. But it will be from very basic, because we're targeting the entire audience. So containers, we'll talk about from very basics. Docker, introduction to Docker Hub. How do you install Docker? What are the Docker commands you run? because that's what this Unix, we are all the time, we are in Unix box, Linux box. So we have to know about this command line. So how to install Docker machines, Docker operations, all using Linux command line. How to build Docker images. We will also build the images from the base image. Suppose if you have Ubuntu as the base image, on top of that, if you want to deploy your application, you deploy your application, you install your application in Ubuntu, then we can commit that and we can make that as an image. So next time when you run that image, you get your application. So that's the main advantage. So in the that's the main thing in the operations, in the DevOps lifecycle. The operations work is so smooth now, because once the developer checks in the code, they install all the libraries, and they using this Docker, they commit this image, and as a tester, it happens automatically. Basically, as a tester, I get the same environment where developer has coded. So there is no environment difference. I'm testing on the same environment, and basically I have automated my scripts. So things are very fast now, continuous now in DevOps. We'll install Docker Compose. That's how, using Docker Compose, I was able to build this in 2 to 3 minutes. Yeah. Okay. So we'll talk about Kubernetes. Why do we need Kubernetes? How it manages the so many. If you have more containers, we use Kubernetes. So it works on the master and the worker nodes configuration. This is the master. This is just a basic architecture. This is not the real architecture. Real architecture is complex here. We have so many things under master, so many things under worker cluster. So it is just to simplify the thing, I have just given this screenshot. So, and we have this pod concept here. So you can see in the pods are nothing but the container. Inside the pod we have containers, and one pod can have multiple containers also. So all depends on your requirement. We will do it. Everything is hands-on. So we will deploy few more. We will provision few more Linux instances in AWS, 2-3 more. We'll make one as master and 2 as worker node, and we will see how the auto scaling is being done. Or even if one of the instances goes down, am I able to access my application? So that's how Google has been managing. They have so many containers, so many pods out there. Even if something goes wrong with one of the pods, google.com never goes down. Yeah, so we'll talk about everything here. Kubernetes, and Kubernetes owns by Google. They have donated this to CNCF. Yeah. A pod deployment, how to deploy this pod, networking, pod lifecycle. We'll talk everything in detail about the Kubernetes here. So basically, these containers and Kubernetes has simplified our in performance tuning process, because they are doing lots of work there. They are making our application fast. But as a performance engineer, we need to learn these things, because if something goes wrong with these things, who will fix this? Right? And we have our own environment, performance environment. So we have to build our own environment using this Docker, Kubernetes, everything, so that we would be responsible for our performance environment, where we would be automating things up as part of continuous testing. So we have to know all these things. Okay, coming to the next slide. So this is how we'll be using Jmeter just for the demonstration purpose, and we'll be using Jenkins as part of this continuous testing. This is where we lies, not just performance testers, but before that, automation testers. The application has to be functionally tested. First of all, no bugs, functional bugs should be there for us to test. It's same concept there, and continuous testing, and everything is automated here. So we'll automate using, demonstrate using Jmeter. We'll automate using this Jenkins. And we'll just get started with Jmeter. So it is, so we are not going to cover Jmeter in detail here. So it will be take a brief discussion about the Jmeter. The idea is to demonstrate this continuous testing process and how we are automating things up here. as part of the continuous testing. Yeah. So Jmeter is not covered in detail here. Yeah. Then we talk about its performance test monitoring and analysis. So we would be taking matrices from the Jmeter run. That's what the analysis of the test results are very important to decide our next steps. So this is very critical skill set for a performance tester or engineer. This is a very critical monitoring. That's why monitoring takes so much of importance. So we'll see how to analyze. First of all, what all we can collect from JMeter. We will see. We'll use this perfmon and jmxmon in JMeter to collect all the matrices, and then we'll collect all this CPU, memory, disk IO, on the network IO swap using this client-side metrics, the end user experience. From server side, we can use this Linux command, top, uptime, vmstat, free, iostat, mpstat. We will see all the things here. So in this, you can see that top has been run here. Yeah. So, and on the CloudWatch, where on the cloud side, where your application is hosted, we will use CloudWatch as well to monitor the application. So we are not leaving anything on the infrastructure monitoring side. Yeah. And for your application, we have tools like JVisual, VM, and JMC, Java Mission Control. So all are free tools. We'll be talking mostly about the free tools here, because once you deploy your application in cloud, you get this CloudWatch. So most of the company would not go with any commercial tools, most of the company, but depends on their application. They may go for any commercial tools as well. But we would be covering JVisual VM on JMC on the process level, Java process level. Yeah, so we'll be talking about this Java from very beginning, from very scratch. So we'll talk about how the JVM architecture looks. So basically, this is how the JVM architecture looks. So we have this memory spaces here, method, heap, stack, PC register, native. We'll see how what all gets allocated here when you run your Java program. So once you have the source code, you compile it, that becomes the class file, right? And then the JVM takes over. All these processes done here will be done here once we get the class file. So method, what will come in method, what will come in heap, how things work in heap, garbage collection. We'll talk about all those things, but here we'll talk about the code part only, how to code. So that's the main important part. So as part of performance engineer, so most of the performance issues are basically on the coding side, and most of the applications are cloud based. Someone has a chat, given me a chat. Yeah, we'll take the question later, Kranti. Yeah, I saw your question. We'll take the question later. Yeah. So, so this is we'll talk about this coding here. Everything from very scratch, because most of the issues, performance issues, are at the Java code level. So either you do heap dump, or you take a thread dump, or you look at any dump. Eventually, you have to understand the code, make the modifications, do a POC, proof of concept there, test your POC, and then deploy your suggested code, optimized code with the main code. So we'll talk about this code part, Java coding. We'll talk from very scratch here. We'll then talk about the Java performance and memory management, how things are being done. Because this is when I talk. So this is the heap I'm talking about in the next slide. I'm just talking about the heap here. So this is how one of the hotspot JVM architecture looks like. So we'll talk about in detail. So what is Eden space, what is SO, S1 survival spaces, how is old memory, how GC is being triggered, how many GC algorithms we have, what is perm gen. From Java 8, we have now meta space. We don't have perm gen now. So from Java 8 till Java 7, we have this permgen space as well. Yeah. So as part of the heap, but now it's meta space native memory. Yeah. So, and we'll talk about this GC log analysis, how to read GC logs, what all things are there. So what you can do, fine tune looking at the GC log, whether your GC algorithm either is parallel or G1 GC or it is CMS GC. Can you optimize things better? How would you go about optimizing it? How will you make the decision whether you need G1 GC implant? Yeah, we'll go about the GC logging. We'll talk about this heap monitoring using JVisual VM. It's there. It comes bundled with Java. If you have JDK in your laptop, you can go to the JDK and build folder. You will see this JVisual VM. And we have this heap dump analysis using MAT. And basically what our intention is to learn the code part. Okay, we'll see, we can find out using heap dump that this method is causing the problem, but what needs to be done to fine tune the bug or the problem, right? So we'll talk about mostly on that. So on the coding side, yeah. We'll also take how to look into heap dump, how to analyze things up. But what do you get from heap dump? You get the troubling the method, right? The method which is causing the problem. And we have to do something on the coding side. So you have to learn code to fine tune that application so that you can talk to the developer. If you have not given the access to change the code, or you can talk to the developer, you can suggest your point of view. That is Java learning coding part is very important here. And we'll use this JMC as Java profiler. Yeah. And we'll see how this Java collection. So it all things are related to Java and its performance. So how array list or linked list, stack, vector, how these things are related to performance, how these things work, how map works, what is the role of hash code, how hash map works, how linked hash map works, hash table and tree map. So we'll see all these details, Java collections and how it is related to performance. Yeah, we'll take so many examples, Java programs. We will write in Eclipse. We'll go over very slowly and we'll understand how things are being done. Yeah. And this would be the last topic. We'll talk about this multi-threading and concurrency and how we can optimize the performance, because the main objective of this multi-threading has always been performance, increasing performance to run the programs parallelly, right? So parallelly, so that we can minimize the execution time, right? But if multi-threading is not being done properly, it can come to a blocking state or deadlock situation where you will find issues. Your application will not respond well, and in that cases we have to take thread dump to understand which thread called by which method is doing all those things. Again, we have to go and understand the code only to fine tune what can we do to resolve this, to handle this particular situation, this deadlock situation, or how can we make things better. So we will go from very basics. What is multitasking, thread-based multitasking, context switching, the impact of performance, thread scheduling, how it works in operating system, thread processes, life cycle of a thread. So this is basically a life cycle of a thread here. So you can see that new, ready to run, running, dead. So at what all conditions it will change their state. So when we take a thread dump, we see all these states here, and then we need to analyze your thread dump to understand which thread is blocking what, where is the deadlock. So we need to, when you take the thread dump, we see that we have to observe all this. So this understanding of all these thread states is very important here. Yeah. So we'll go on the demo. Before that, we'll show this AWS, also Docker and AWS console. So before that, if you have questions, please. Yeah.
What will be the duration of this course?
So this is around, we are targeting around 30 to 35 hours, maybe 40 hours, depends on how deep we are going into each of the topics. Suppose Java, if people are new to Java, we may have to go for more number of classes to understand things better, because we are starting all the topics from very scratch. That's the main agenda. There has to be takeaways. It's not like I'm doing something and they're not learning. So people are not learning. We'll again start. We'll make sure that we are all together in this. Yeah. So it mostly, to answer your question, 40 hours, 40 to 45 hours. So maybe around 1.5 months to 2 months. You can just consider like that. So 5 days a week. We'll meet in the morning, 7:15. We'll go for 1 hour mostly, and depends on, we'll have a logical ending for all the sessions. So it may go for 1 hour 50 minutes or 1 hour 30 minutes at max. Yeah.
So on a high level, it's around 2 months.
Around 2 months, yes.
Thank you.
Yeah.
Roshan, coming to this cloud performance engineering, like AWS1 Docker and Kubernetes, like this one installation and this part is covered, or see, like when you come to an engineering part, like see what are the major component which is improving performance and how to optimize it, how to monitor and optimize it, and those part will be covered in detail, or how it is?
Right. So to understand how things are being monitored, what needs to be done, so we need to first understand things, right? We need to understand
Yeah.
how to go about installing Docker and Kubernetes. So
Yeah.
we have this in Docker. If you look at, I'll show you in AWS, we have this CloudWatch Insights, we call it. We monitor the containers there, and even we can monitor the containers using Linux command line. We have Docker stats, right? So if you have your application running, right, if you have your application running in your Linux instance, you can use this Docker stats to get all your matrices, right? So your CPU, memory, and all those details. So we will go over. See, the idea is to what? The idea is to run your test. First of all, your application has to be deployed using these things. It has to be deployed in cloud. It has to use container, Docker, Kubernetes. We will test it out, how things are being done. And if we have issues, we need to monitor things up first, right? That's for always a thumb rule for any performance test. We need to monitor things up. And then if we have any issues, yes, we have to resolve that, right? Yeah. We have to see where is the bottleneck, what can we do to resolve that, yes.
So those use cases also will be covered as part of all the three AWS core, Docker as well as Kubernetes. Is it? What are the like you said in Java, like we do have we have a heap and runtime data is a heap, and say some the major Java optimization goes into runtime data areas. Like we face an out of OIM error, we how to extract and heap dump, and how to find out the particular method in MAT, and we further go it. Like, and we do have an use case like what your experiences into for the past in the cloud performance tuning. We do take an use case and we can walk through how it is like covered in such a manner, or in AWS Docker and Kubernetes, or
See, this Docker, you need to understand where this comes into picture. See, this Docker Kubernetes is on the environment side, right?
okay,
You build the environment using Docker containers, and Kubernetes is, suppose you have many containers, that's when you use Kubernetes. But basically you have the containers only, right? So you basically you need to know how to monitor those containers, right? So in AWS, we have CloudWatch. I will show you what all graphs we will see, okay? I will show you in some time, okay? In CloudWatch, what all graphs we will see. And to monitor the containers, see, CloudWatch is for the infrastructure monitoring. You get to see ECU, your infrastructure, how would be the CPU, memory, and all those packets, network packets, and all those. And CloudWatch Insights is dedicated for the container monitoring. Containers monitoring, and we also have Linux command to monitor the containers. So once we install the Docker, I will show you those commands as well. Yeah.
Okay,
And
one
then
last
we have
question.
to see the logs. But if we are running into any issues, we have to go and check the logs. How about the Linux performance? How were you measuring the Linux performance? Yeah. So it is the same way how you were doing the Linux performance. Suppose the bottleneck is on the performance, the OS side, Linux performance, right? Your issue is not at the Java code level. Your issue is at OS level. How would you go about it? You would need to understand which component is causing the problem, where we are seeing a high usage, right? You need to all the metrics, right? Similarly, have this Docker and containers, because consider as Docker container as the environment side, right? It is not on the application side, right? It is not a Java process, right? It's still a process, but it's not a Java process. If it is running bad, if it is not performing well, we can check from its how much resource it is consuming and how to go about fixing this. We have the logs also in Linux operating system. Also, we get logs. Similarly, in the Docker container, we see logs and understand what can be done to resolve this. Yes, yeah.
Okay. One last question, like in the AWS, we do monitor all the key services, like, or only EC2 will be covered as part of the like EBS
No.
and this.
CloudWatch monitors everything. I will show you. Okay, I will show you CloudWatch in some time. You will understand what all matrices comes there. You will see live. Yeah.
Roshan, one question from Kripa here.
Yes. Hi, Kripa. Yeah. Tell me.
Yeah, as you were saying about CloudWatch side, are you going to help us understanding memory monitoring for the containers or pods from the CloudWatch?
You're not audible, Kripa. Can you be audible better? Yeah. Can you repeat your question?
How about the memory metrics from the CloudWatch? Are you going to give some sessions for the memory side monitoring, because that seems to be quite challenging in the cloud infrastructure, right?
So if that is the constraint, so we have to use the native command line only, right? So that's the reason we are also covering the command line, so that see, AWS, they are developing day by day. So if you look at AWS 6 months back, they have developed a lot. They are still developing a lot. So maybe they can come up with the memory part also, but wherever is the bottleneck, we can use because it's still the same Linux, right? It is the same Linux. We can leverage these native tools to monitor all those things, right? We can write a shell script to keep monitoring these things when a test is running, right?
Yeah. So those shell scripts kinds of things, what you are talking, are we going to cover in the sessions, or we have to have separate?
No, we can not now. Yeah, we can cover that. Shell scripting is just, see, if you know about what all see, if you know about this free IO stat or MP stat, about these things, you can write a shell script. So we can go about writing a shell script also, so that during the test you can start your shell script. Okay, it will be keep on monitoring. It would keep on logging all your matrices, and after your test result, you can import this to CSV and you can plot your graphs to see how are things, how was my performance, Linux performance, right? Yeah. So we can do that. Yeah.
Okay. Cool.
Yeah, extending to this question, that memory part, like, if suppose like a microservices application, then we will have multiple instances. Then how what are the tools we'll use for monitoring these multiple instances along with a lot of microservices? How to tackle those a lot of things, and because as you mentioned here, there is no tool that is covering the instances and memory part, except this AWS CloudWatch. If I have the private cloud, how to do it?
For the Kubernetes you're asking, right?
Exactly, Kubernetes, yes.
Okay, so yeah, Kubernetes, maybe I'm not sure on that part. I'm sure about the containers, how to go about it, because in the Kubernetes we have lots of containers, and master does the most of the work. Suppose if any pod is not working, so master will take care of most of the things here, right? but we have so many containers. Yeah, I'm not sure on that part. Yeah, Kubernetes.
Yeah, that's right.
Kubernetes. Yeah.
But is it I mean, like, is it okay to include that thing in these sessions? I mean, like, I mean, later.
Yeah, we can explore on that. I can basically see as per my exposure, yes. So we can explore on that part because we know how to monitor one Linux instance or how to monitor one container. But if you have, suppose if your application is like 500 containers, so we have to come up with some tool. I'm not sure about that tool. If Kubernetes had some tool, but I'm talking. I know about Prometheus and all. So we can install Prometheus, but that's not covered here. That's part of the DevOps basically. So on the container wise, yes, we can cover. But if you have many containers like Kubernetes as you're talking about, I'm not sure on that part. Yeah.
Okay. So, sorry, Kranti, sorry to interrupt here. What I'm understanding from Kranti's questions here. Let's say we are having such kinds of issues, and in that case, can Isha Training provide some special sessions, 1 sessions, or maybe half an hour or 1 hour sessions to understand how we can do such kinds of special kinds of issues if we are encountering, and which should be ideally coming under this, but can we get some special sessions or expertise advice, Roshan?
Okay, so like as per my understanding, you can talk to Kumar here. This is his number,
Okay.
right? So you can see
Yeah.
this is a number. So this is
Yeah,
his
yeah.
number. Talk to him about this, and even I
Okay.
can explore from my end because I'm not
Yeah,
aware
definitely,
of this.
definitely.
Are you do you aware of this such a tool, Kripa? Because you have been performance architect from quite some time now. Are you aware of such a tool which
Yeah.
can?
Yeah, well, that is why I'm also encountering similar, memory kinds of issues. Some certain, memory leaks from my one of the environment. It's kinds of dev environment where we are encountering at the moment memory leak, but there is no as such mechanism at the moment to capture those stats. So I'm also not aware about. As I said, X-ray is one of the things which we are using to find out the particular microservices if something is down or up or broken.
Right.
But complete the containers perspective, yes. Sorry about it. I'm also not aware, and I thought we'll check here in this session.
See, container monitoring is one thing, and Kubernetes where we have 100 and 200 of things, it's a separate thing.
Yeah, definitely.
We rely on this master configuration, this master to take care of all the pods. If any pod is not performing well, right, the master takes care of that. So this is how the Kubernetes is built, right? So we can explore on that part. See, even now I have got this question for the first time. So even I would go and explore that.
One more thing would like to highlight here, Roshan. What other thing we are encountering, I'm encountering specifically with this master slave configurations. Whenever the load increases and a new, the orchestration happens, new clusters build up. In particular, that the design of that particular cluster, the performance really deviates significantly because the traffic is load is continuously coming onto the servers. Servers are not capable to handle. System is designing the new the cluster, but in between that design process, that particular moment of the the seconds or milliseconds, the response time shoot at like anything. And that kind of thing. Yeah.
So that was the main reason why the Docker Swarm is not that popular, because Kubernetes seems to be a very mature model, and if you have been doing load test, if you have been doing load test, and if you're encountering this, we need to look into this. I have not encountered such issues, but we can try simulating such issues. And,
definitely. Yeah.
can see
But
how.
altogether, it's really based on the syllabus. I'm finding like it's a good one, a nice journey ahead,
If
and it
you are
will be
commenting
really.
about that because you are being such an experienced guy yourself, but this course was designed considering the current market trend. Okay, so
Exactly. You can't
because
believe
now,
the day before yesterday, I had attended one virtual summit, CMG summit, where all those big fish were there in USA. It was like very night time for my 12 a.m. to 6 a.m. I attended that session. And they were discussing all together these things, particularly only DevOps, cloud DevOps, and that CMG was basically that virtual session summit was for performance engineering, and they covered most of these things which you
okay,
are explaining here.
if you want my honest opinion, right? I am like, since I am also in this field from quite some time now, so we need to be now. Things are getting very simpler, right? I would say, like I would like to demonstrate something on the cloud before we over our time. Okay, so we need to learn these things very quickly, and we need to also as a performance engineer. See what all we need to do. We don't need to be a DBA, right? But we need to learn
Yeah,
database also, right? But
exactly.
DB is not considered as part of this syllabus because again that would take 2 months again. So that part is not being covered here. To be you can just note this down because we have a separate session or a batch for that. So as a performance engineer, we have to learn about all these things. We have to learn about cloud, we have to learn about DB, we have to learn about application server, we need to learn about the tool, we have to also learn about the networking. We have to have our foot everywhere, right? To understand
Exactly.
to understand the application and to resolve any performance issues. So this course was designed considering that, and it's
Mm-hmm.
maybe in 2 to 3 years we have to learn all of DevOps because things are getting automated. Suppose
Yep.
if you look at this DevOps life cycle, once if the requirement is there to have again a new Jmeter script, suppose if the new requirement
Mm-hmm.
came up, we as a performance tester or engineer, we have to design one more Jmeter script. But apart from that, if if you're not having the requirement, things are automated, right? Where what
Mm-hmm.
would be our role? Things are automated.
Exactly. Mm-hmm.
The performance test will kick off automatically and you will have the report in your email.
Yep.
This is how the things have been done in DevOps.
Exactly.
Based on this container and Docker technology, right? Things are getting that there is no dependency on the developer side. Mostly in Agile, what we complain, this application is not well out, this that, but coming of this thing, coming of this Docker, this environment issues will go off, right? And
Mm-hmm.
we can
Mm-hmm.
automate things up. So we need to increase our domain to DevOps also. How automation is the next thing. We need to also learn
Yep.
the automation. We can come up with some
Exactly.
tools. So this Java knowledge and cell scripting knowledge is very PL SQL knowledge that I'll cover in my next training in the DB training. PL SQL was for why do we need PL SQL? To create the performance data, right? Suppose we can
Yep.
directly insert those records in the DB. So we
Mm-hmm.
need to come up with we need to know a lot of things as a performance engineer. So yes,
Yeah,
but
definitely. Yeah, definitely.
to answer your question on the container or orchestration, Kubernetes monitoring, no, I'm interested to figure out how it is done. I've not encountered such things.
Yeah.
Okay, so can we start with a few demo for the folks who are looking at things new? Because I understand here people are aware of this AWS and all, but many of them are not. So can we start with this AWS demo or Docker, or we can do this in the next demo? I'm okay with that.
For me, if you can cover in next would be much better because it's like I took 1 hour break from my work. It's 1 p.m. now, so I have
Okay,
another
I
meeting.
will just take 5 to 10 minutes. Okay, for now, I will not take
Yeah,
more.
go ahead. Yeah.
I'll not take more. Okay, so
Yeah.
just to give what all we're gonna cover in the next demo session. So this is my AWS account. We'll all create our AWS account. Okay.
Okay.
We'll all create our
I must be
AWS.
having mine one, yeah.
Right. Yeah. It is free, and we just need to put our details. They don't charge, but yeah, we need to put our details there, credit card details. Okay.
Yeah, 700 hours are free actually.
Right. So we can leverage that part, and we can learn things up here. Okay. Because nowadays companies are asking, do you have, because this cloud will be the future, and they are looking for some cloud knowledge, guys. Nowadays, this earlier I used to see the job description as cloud knowledge is a plus, right? Is a plus, but it's a near future. It will be a must for sure. Everyone would have to know this AWS, because everything happens from here. You can provision all your servers from here over the internet, just using this console. Earlier, I remember my days where I used to work in on-prem environment. I used to virtualize things up. I used to have this big Linux box where I used to virtualize things up. I used to set up all my application components separately, do my networking done in place, and then on top of that, I would deploy my application and test it. But they have automated those things here. Within the clicks of the button, you have your application ready. Yeah. So this is the AWS console, guys. So if I'll not take much time, Kripa. I understand your time commitment. So it's already been very late for you, and we have already covered 1 hour, more than 1 hour. So maybe 5 minutes you can bear with us, and then we can pick this up, all our demo sessions in the next.
No, go ahead. I have meeting at 1:30, so 1:30 Australia time. So
Okay.
I have another 25 minutes, 20 minutes left.
Right. So we'll not take more than 5 to 10 minutes. Okay. So this is AWS console, and we all will have this account. So you can see I have used this Mumbai as my region. I have deployed my this is called region. We'll go over this in detail. Just try to just listen, and if you're not getting it, no worries. We'll go over this in detail. What is a region? What is availability zone? So what is fault domain? We'll talk about all this thing in detail. So I have created my account there in Mumbai region. So, and look at the services offering, how many we have in AWS. When they launched, it was just EC2 and few others, VPC and S3, but now they have so many, and they are still developing, and it will keep on developing. So where we are, we'll go to EC2 here. Okay, so I have my 2 instances running. So this is the VPC networking in place just for our internet connectivity. So they have given a default, but we will create our own VPC. If you see my Linux, my running instances, you can see my 2 of the instances here. This is my Linux instance, and this is my Windows instance. Okay, so I can provision. We have this launch instance, and we have this entire process. We can use this free tier. We'll go about this. Okay, how to go about this. So let's not go there today. So this is EC2, and this is my instances. And basically I can log into this my instance. So if you come here and if you check my IP here, I have got this is my public IPv4 IP. This is my public IP, and this is my private IP here. This can be accessed from the same region, but this can be accessed over the internet. So I will first log into this instance. Okay, so this is a partition. We have this. I have created this. So this is the same IP I'm giving here. If you can notice, 15.207.20.123, same IP. I'm trying to log into this Linux instance here, and we need to set up some keys and all. I'll talk about that later. So yeah, you can see this coming up. So this is my EC2 instance, guys. So I'm Ubuntu. So I have, this is my Ubuntu instance. So that's the reason I'm showing Ubuntu here. And to show you, I had deployed one web page. I installed the Apache server just to see the connectivity, if I am able to connect it properly or not. So I have this, see, this guy, I have installed this Apache 2 in 80 port. You can see this, I have deployed this in the morning when I was trying. And once you go to this location, I need to be sudo. I hope you guys can see my screen, right? Or I need to change the font and all. Hello.
Yeah, we can see.
Okay.
Yeah, I can see it.
So, right. So if you can see here, this is index.html. I just modified. Okay. Yeah. So we will be practicing all our commands here in this Linux instance. So if you see, this is the page, HTML page is being displayed here. So yeah, we can modify this HTML page just to make sure our connectivity is fine or not. In the morning, I checked before the demo session. Welcome. Yeah, so this is what is being displayed here. If I change this here, just for the confirmation, I do that. So it's working fine or not. So let me just edit something and show you guys. So this is just for a simple connectivity, nothing else. It is not like I'm showing you how to deploy the application, but you can deploy it basically. So I have just saved it and I will refresh this page. You can see this, thank you. So this is over the internet, guys. So I can ping you. You can also check this. This is over the internet, 8080 port. So the things are like that. So in EC2 instance, we can deploy our application. And we also have Docker installed. I have also have Docker installed. So let me just see that. Okay. If I do Docker version, see, I have this Docker installed also. If I do a Docker PS, you will see the containers. Yes, I deployed this yesterday night. In 5 minutes, we have this LAMP server, web server, MySQL. So it's a real-time application. I'm not talking about one simple web page here. I'm talking about a real application. We will install Docker Compose. We'll have our YAML file, and we will do that. So if I have to show the YAML file, just hold on. Okay, so basically, I had this YAML file. I created this YAML file for PHP, for HTML, and then I use Docker Compose to get this application work running. So if you look at the YAML file, we'll be going over that. So don't worry if your things are overwhelming to you guys. So we have this Docker file, php.docker file. We'll take the image from there and we'll do some port mapping. We'll do some port mapping and all. Then we can get our application running. So I will show you that application, whether it's working or not. Where is that? Okay. Okay. Okay, this is the URL. So I use 5000 port. If you would have noticed my YAML file, and it's the same IP address I'm using because I'm connected to the same EC2 instance. And if I log in here, you can see this my application running here. This is the PHP server, and this is my web server. So it's working. Yeah. So we will deploy our application basically in Docker. We will learn how to operate things up here in Docker. Yeah. Okay, guys. So we'll talk about the next demo. We can have the next demo. We can show what all we're gonna cover. Or if you have more questions, please come up for the next demo session. You'll be notified in the same WhatsApp group uh, about the session, and then we can take it from there. And if you have some more questions, what all you're gonna cover and all, the Java coding part, I can show you all the code that we're gonna cover, everything. Maybe in the next session, Eclipse, we'll open Eclipse and show it. And yeah, things will be like that. So if you have any expectations, please let me know. Yeah.
Thanks, Roshan. So tomorrow, the same time, you have this.
I'm not sure about tomorrow. That Kumar will update on that. So you can reach out to Kumar at this number. This number is being displayed, right? Please note down this number if you have it. And he's also in the WhatsApp group. So we will be informed about this. Maybe over the weekend we don't do. So maybe on Monday we can set up a next demo, and we can do that. If you guys have questions, please, if some expectations, please inform me. Yeah, let me know. Yeah.
And post this demo, the session's gonna happen on the same time, right? The actual
Right,
session.
same time we're gonna cover everything. Yes.
Yeah, same time in the sense, like, the 7 a.m.
7:15. Yeah, 7:15. Yeah. Mostly we'll start by 7:20, and then we'll wind up mostly 1 hour. We'll have a logical ending. It's not always fixed 1 hour. We can stretch 5 minutes here and there. We'll have a logical ending of that particular topic which we have taken up. Yeah. And we'll go slowly. We are all together on this. So yeah.
Thanks.
I think we are good. Hello guys. If you are good, we can close this session today. And please reach out to Kumar sir for any payment related things. Yeah.
Thank you, Roshan. Thanks for your time. Thanks, everyone.
Thank you, everyone. Yeah.